Today, we're doing a masterclass on a substance that silently prevents catastrophic metal-on-metal failure. We're talking about automotive grease. We rarely think about it until something goes horribly wrong, but this complex chemical cocktail is literally the unsung hero of your vehicle's mechanical health. We're kicking things off by busting a massive workshop myth about grease colors, because getting this wrong can absolutely cause your vehicle's wheels to seize up at highway speeds. You've probably stood in the auto parts aisle staring at a whole rainbow of tubs, wondering if picking red over blue actually makes a difference. Well, the answer is both yes and no, and the chemistry behind it is absolutely fascinating. All right, let's dive into the masterclass. We're going to cover 5 key areas today: diagnosing degraded grease, decontamination and old residue, the color-coding decoder system, chemical incompatibility risks, and finally, safe application and packing. Section 1. Diagnosing degraded grease, recognizing the warning signs. Before we get our hands dirty, we need to understand what grease actually is. It helps to think of grease as a chemical sponge. The thickener literally holds the oil in suspension until mechanical stress squeezes it out to lubricate a joint. It's actually a non-Newtonian fluid. When it's just sitting there, it acts like a solid to seal out dirt and water. But the second your wheel bearings start spinning, that mechanical stress shears it down into a fluid oil film. Once the spinning stops, it goes right back into its sponge-like state. It's brilliant. Now, the absolute crucial takeaway here is that true performance is dictated by these 3 technical metrics on the datasheet, not just whatever dye they used in the factory. First, the NLGI consistency grade is your stiffness. Too thin, it leaks out. Too thick, it won't flow. Grade 2 is the automotive standard, and it actually has the exact same texture as smooth peanut butter. Then you have the dropping point. This is your thermal sealing. If your brakes heat up past that dropping point, the sponge completely collapses, the oil leaks out, and your bearing dies. Finally, viscosity is the actual thickness of the oil hiding inside that sponge, doing the real heavy lifting. So you'll want to inspect your components for these specific symptoms. If you see a hard, crumbly crust, man, your bearing is basically chewing on dry metal. A milky or cloudy look, that means water has breached the seal, creating this terrible emulsion that practically invites rust. And if you notice a blackened color or a charred smell, that grease has surpassed its dropping point. It's totally cooked and it needs to go immediately. Section 2. Decontamination and old residue, the clean slate protocol. You cannot just pump fresh grease over a hardened crust filled with abrasive road grit. To get down to bare metal safely, you've got to follow this decontamination process. First, mechanically remove the bulk debris with a non-marring plastic scraper. You definitely don't want to scratch the bearing surface. Next, saturate the internal channels with a fast-evaporating automotive brake cleaner. Let that solvent work its magic to dissolve any hidden, trapped metallic debris and stubborn chemical films. Then, wipe the surfaces bare with a clean, lint-free shop towel. Oh, and definitely use a towel-wrapped pick to clean out those recessed circ fittings. You want to ensure 100% of the old grease is eliminated to prevent cross-contamination. If you skip cleaning those little metal fittings you attach the gun to, you'll end up injecting abrasive road grit straight into the heart of your bearing. Section 3. The color-coding decoder system, decoding the rainbow. With everything flawlessly cleaned, let's decode the colors so you know exactly what you're reaching for. Red is your high-heat workhorse, while blue acts as a heavy-duty waterproof shield. Red grease is usually a high-temp lithium or aluminum complex, and it's incredibly popular because it handles the intense radiant heat bleeding off your disc brakes. Blue grease, on the other hand, is this tacky, stringy formula with elite water washout resistance. So if you're backing a marine trailer into a muddy lake, the water won't wash the lubrication away from your chassis points. Now, when we shift to green and black, the applications get highly specialized. Green is a synthetic polyurea built for clean, high-speed spinning. It has massive oxidation resistance, making it perfect for electric motor bearings. Black or gray grease, however, is infused with solid molybdenum disulfide, or moly, to survive brutal, heavy-impact shock loads. That black grease is actually fascinating. When extreme pressure squeezes the liquid oil out of a CV joint, those solid moly particles literally plate the microscopic valleys of the metal, stopping the parts from scoring each other to death. But you would never use it in a high-speed wheel bearing, because those solid particles would just cause the rollers to skid. Finally, white, amber, and yellow greases are your light-duty domestic options. These are completely unsuited for high-load powertrain components. White grease is a clean, non-staining lithium base strictly for things like door hinges and seat tracks. It usually contains zinc oxide so you don't ruin your clothes if you brush against it. Amber or yellow is just your standard low-cost general-purpose calcium grease. It's suited only for low-load, low-heat parts. Now listen to me carefully here. I literally cannot emphasize this enough. Color is just a helpful manufacturer dye convention. It is not a universal rule. You must always verify the underlying chemistry on the technical data sheet. Because there's no strict international law dictating grease colors, a manufacturer could easily dye a cheap, low-temp lithium grease red. The color is just a dye. The true engineering spec is always on the back label.
Section 4. Chemical incompatibility risks, the hidden danger of mixing.
This brings us to a really stark warning about what happens when you ignore the chemistry and just mix different greases together. Mixing a polyurea grease with a standard lithium grease is a recipe for absolute disaster that will destroy your machinery from the inside out. Remember our chemical sponge analogy from earlier? When incompatible chemical thickeners meet, they actively attack each other. The structure of the sponge entirely collapses. This nightmare scenario is called the phase separation pipeline, and it highlights exactly why our decontamination step was so vital. Leaving old, incompatible grease behind triggers this exact chain reaction. Step 1, incompatible thickeners are forcefully mixed inside the bearing. Step 2, chemical phase separation instantly begins. Step 3, the thickener hardens into a useless crusted wax. Step 4, the vital base oil entirely leaks out of the assembly. And Step 5, unlubricated metal-on-metal friction leads to total component seizure. You might look at it and think your bearing is fully packed with grease, but what's actually in there is a hardened crust holding zero oil. The base oil just drips out onto the driveway, leaving your bearing to literally grind itself into catastrophic failure. Okay, a massive safety warning right here. Never use standard chassis grease on brake systems. Automotive chassis grease will literally destroy the rubber components in your braking system. You should only ever use pure silicone paste or ceramic lubricants on brake hardware. Petroleum-based greases will melt right onto your brake pads and cause those rubber caliper seals to swell up and stick. Plus, standard grease cannot handle the 1,000-degree temperatures of braking. It'll just melt, run down onto your friction pads, and you'll suddenly find yourself flying down the road with absolutely no brakes. Section 5. Safe application and precision packing. Precision in practice. Now that we've got the right chemically verified grease in our hands, let's talk about the mechanical art of applying it correctly. When you're packing by hand, manually force fresh grease deep through the bearing rollers until it flows out uniformly. You've got to ensure absolutely zero air pockets remain inside those rolling elements. If you're using a grease gun, monitor the sealed rubber boot closely and stop pumping the exact second it begins to swell even slightly. If you overpressurize that component, you will blow out those delicate rubber dust seals. Then wipe away all the exterior excess grease. Exposed grease acts like a magnet for dirt, effectively creating a grinding paste right next to your clean bearings. And finally, always snap a clean, protective rubber cap over the Zerk fitting to seal out any future environmental contaminants. So, take a look under your car this weekend, armed with all this chemistry knowledge. Are your vehicle's joints thoroughly lubricated and surviving? Or are they quietly waiting to seize? Are you unknowingly running a melted, incompatible, waxy crust inside your CV joints right now? It's time to check those technical data sheets, properly decontaminate your hardware, and treat your lubrication with the precision engineering it truly deserves.